Hello everyone, today we will be seeing how to interface Arduino UNO with NRF module. The required components are Arduino UNO, NRF module, a Tenet GPIO board, a Tenet power supply board, a Tenet relay breakout board, L293 motor driver, bulb, breadboard and few jumper wires. Now let's see how each and every component works. First we'll take up an Arduino. Arduino is an open source prototyping platform based on easy to use hardware and software. Arduino is based on Atmega 328P microcontroller. It has 14 digital I/O pins, out of which 6 are PWM pins. Each pin provides 5 volts, and where you can connect different types of digital sensors. And it has 6 analog input pins and power pins. Power pins produce 5 volts and 3.3 volts. And it has 6 analog input pins where you can connect different types of analog sensors to it, and it has 10-bit ADC. The Arduino can be powered up by using an external power supply or USB jack. It has a 16 MHz crystal oscillator. The Arduino can be programmed by using an Arduino IDE software, which is easily available in the website. The NRF module is a single chip 2.4 GHz transceiver which has enhanced shock burst protocol engine embedded in it, and it has a 16 MHz crystal oscillator, and it has 8 pins which can be operated and be configured through SPI, and which is suitable for ultra low power applications like 3.3 volts. The NRF supports on-air data rate of 250 kbps, 1 Mbps and 2 Mbps. It can operate in standby mode and powered on mode, which makes it more suitable for ultra low power designs. One of the most advantage when comparing with other devices is that the transmitter can get to know whether the sent packet has been received by the receiver or not. If not, it automatically retransmits the packet, and it supports point-to-point and point-to-multi-point communication. Now let us see about the Tenet Tech GPIO board. As the name itself suggests that it is a general purpose input-output circuit which has 4 push buttons connected to it, which produce high or low signal when pressed, and it has a buzzer, a T-SOP receiver, a 7-segment display, LM35 temperature sensor, potentiometer, LDR and few LEDs connected to it. The general purpose input-output board can be used with any of the microcontroller, which makes it suitable for carrying out quick experiments, and it can be used to access numerous peripherals, and which minimizes the breadboard connections. Now let's see about the Tenet Tech power supply breakout board. This breakout board produces different voltages like ground and 3.3 volts, 5 volts and 12 volts. It has a 7805 voltage regulator which produces constant voltage of 5 volts, and LM3117 voltage regulator which produces constant voltage of 3.3 volts, and few capacitive filters to reduce voltage fluctuation. This is the Tenet Tech relay breakout board used to control AC appliances through DC, and this is the BC547 transistor which is used to switch the 20 amps relay. This relay breakout board control kit contains all the parts you need to get your high power load under control, and screw terminals on the other side, which makes it easy to incorporate into our project. This is the L293D motor driver. It is a quadruple high current half-edge driver. L293D is designed to provide bidirectional drive currents of up to 600 mA at voltage from 4.5 volts to 36 volts. It is capable of driving inductive loads such as solenoids, relays and motors at high voltage or high current in positive supply applications. Now we are using a DC motor which is connected to a fan. This DC motor is driven by the L293D motor driver, which is not capable of driving by the Arduino, so we use a L293D to drive this motor, and we also use a bulb, 230 volts bulb and 12 volts 1 amp adapter, which is given to the power supply breakout board, and few breadboard and jumper wires. Now let's see the interfacing of NRF module with Arduino UNO in point-to-point communication. The NRF module 1 acts as a transmitter, and the NRF module 2 acts as a receiver. The NRF module 1 is connected to one Arduino, and NRF 2 is connected to another Arduino. This is the Tenet GPIO board where we use the push button to switch the bulb, and all these are powered up by using a Tenet power supply board. 230 volt is switched by using a relay breakout. Now whenever I push the button, you can see that the bulb glows on. The NRF module 1 sends the data to the NRF2 to switch on the bulb. Let's see the interfacing of NRF module with Arduino UNO in point-to-point communication. NRF1 acts as a transmitter, NRF2 is a receiver. NRF1 is connected to one Arduino and NRF2 is connected to another Arduino. Here we are using a LDR in the Tenet GPIO board. A LDR is a light dependent resistor whose resistance varies whenever the light intensity is incidented on it. All these are powered up by Tenet power supply board, and 230 volt bulb is switched by relay. Here you can see that whenever the light intensity crosses some threshold, the NRF1 wirelessly transmits the data to NRF2 to switch on the bulb. Now let's see the interfacing of NRF module with Arduino UNO in point-to multi-point communication. The node 1, which is the NRF module 1, which acts as a transmitter, and the node 2, which is also a transmitter, and node 3, which is the receiver. The NRF module 1, 2 and 3 are connected to different Arduinos. The NRF module 1 and NRF module 2 is connected to the push buttons using Tenet GPIO board. The NRF module 3, which is used to switch the bulb and motor, the motor is driven through L293D motor driver. As you can see that whenever the push button 1 is pressed, NRF module 1 sends the data to NRF module 3 to switch on the bulb. And whenever the button 2 is pressed, the NRF module 2 sends the data to node 3 to switch on the motor. All these nodes are connected in a point to multi-point network where each node has a unique address.